Very happy to have Nikita Sangwan from the ISI Delhi, who's going to talk about gender effects of climate change. For half an hour, I will probably, with 10 minutes to go and 5 minutes to go, I'll just interrupt, unmute myself and let you know so that we can keep to time. All right.
Thank you, Kanishk, and thank you everyone for joining in for this presentation. Today, I am presenting the gendered effects of climate change. This is co-authored work with Farzana Afridi and Kanika Mahajan. And in this study, we are trying to examine the gender differentiated labor impacts coming from a negative productivity shock, that is drought, which has become all the more prevalent because of the climatic changes. A quick overview. So I will start with the motivation of the idea, then come to the data, a novel data set, which we are using here, then explain the estimation strategy, which is followed by the results and the robustness check on those results. Then we delve into the underlying mechanisms and try to decipher what is leading to the results that we are observing, and finally conclude. Starting with the motivation, so we all know that climate change has led to increased rainfall uncertainty. And because of this, we are seeing an increased incidence of extreme events like drought. Here is a graphical depiction of the 5 year moving average of drought experienced across the Indian landscape between 1901 to 2017. And we see that there is a clear upward trend in the incidence of drought. Also in the future there is prediction that we are going to be facing more of these extreme events if climate change continues unabated. This is going to have severe consequences for the agriculture sector, as more than 75% of the world cropped area is still dependent on rainwater. Also, this is a major concern in the developing countries where the agricultural systems are largely rain fed and managed by some of the poorest communities. There exists literature that has established that drought have huge economic cost in terms of the agricultural output, the income of these farm households, and they pose a threat to food security. Also, given that a significant chunk of the workforce in developing countries is dependent on agriculture as source of employment, that is going to come under threat. Now, the thing is, when there is a negative productivity shock, the farm sector jobs dry up, and at the same time the return from working on your own farm also goes down. So because of this there is going to be a push towards diversifying to the non-farm sector, but the ability to diversify and also the effects on male and female labor might be different because of this negative productivity shock. And that is what we are trying to address in this study. We first examine what are the labor market impacts of this negative productivity shock, and then try to examine whether there is a gender differential in these effects. So the existing literature has majorly focused on the agricultural impacts, wherein they are trying to see what is the effect on the measures of farm productivity, which is captured by the crop yield and the income of farm households. And these studies do find that there is a significant loss happening because of deficient rainfall. But when it comes to the labor impacts of rainfall shocks, there are very few studies. Jayachandran's paper was one of the early and initial studies that looked at the effect on the wages of farm labor. And they also found that if there are avenues to do non-farm work, then the negative effect can be partially offset. More recent studies have also delved into diversification to the non-farm sector, but these studies have not explored the gender perspective. And the studies that do address the gender differentiated impacts are largely focused on the loss of assets and human capital accumulation. When it comes to the gender differentiated labor impacts, the literature is almost absent there, with a few exceptions, the study being by Mahajan in the Indian context, where she explores the effect on the wage ratio of men and women, and the study by Kemi in Uganda, where they're looking at the time spent in fetching water. But to the best of our knowledge, we know of no study that explores the gender differentiated labor impacts coming from rainfall shocks and how the labor market can be used to smooth out the negative effect coming from such a shock. Therefore, we are adding to the literature on multiple fronts. Firstly, we are adding to our understanding of how labor response, how labor, which is the individual as well as the farm households, how they are responding to these aggregate productivity shocks. uh, Also, these results are generalizable to the impact of aggregate productivity shocks where there is a gender division in the tasks done in a specific sector. Now, the previous studies were majorly looking at how the income sources are getting diversified, while we are able to explore the decisions being made in the labor market. And this is important from the policy perspective to make these agricultural systems resilient to climate change. Also, a key feature of our study is the unique data set that we are using. While the existing literature has examined the effects looking at more aggregated geographical data and mostly doing cross-sectional analysis, uh, wherein they explore the effect on districts or state level data, we are able uh, to do a more disaggregated analysis using the VDSA study conducted by ICRISAT, which provides us data at a monthly frequency. An added advantage of using this data is we are able to do an operation level analysis, which has been hitherto missing in the literature and is important to understand the effect of these shocks because certain operations may be affected differently when there is a deficient rainfall. Finally, we are bringing in the gender perspective, wherein we are trying to explore the gender differentiated impacts on the usage of female and male labor and the labor market responses of the female and male individuals. And we also explore if the coping mechanisms adopted by these individuals, they have a gender differential. A snapshot of our key findings, we find that the total female labor usage on farm is falling significantly more for female labor, and the magnitude is pretty high. It is falling 31% more for female labor than that of male labor. Now, these households that are affected by these shocks are coping up with the shock. They are not able to fully cope up with the shock, but they are partially offsetting the loss by diversifying to the non farm sector. And that is happening largely through the migration of the male members of the household. On a general front, our findings are adding to the understanding of these negative productivity shocks because we find that even within a sector, there can be differential change in demand for tasks. Therefore, the division of labor matters to how the labor markets are disrupted by a productivity shock. Now, let's get started with the data. So, our labor and agricultural data is coming from a panel data from the second generation study of ICRISAT. Okay, this study collects data from the semi-arid tropics of India, which are shaded in red color, and humid tropics, which are shaded in the green color. The semi-arid tropics are characterized by very less rainfall and also lack of access to irrigation facilities. The humid tropics, which are in the eastern part of India, are characterized by hot and humid temperatures. Now, the dots here represent the surveyed villages. So there were total of 18 villages surveyed in the semi-arid tropics of India and 12 villages that were surveyed in the humid tropics. And within each village, 40 households were surveyed at a monthly frequency. So in our analysis, we are using the farm household input panel, which is compiled using the cultivation data from 2005 to 14 from both of these regions. And we have aggregated it to the season level and disaggregated it by operation so that we are able to do a season level analysis and also look at the usage of different type of labor in different operations. And for our individual employment panel, we are using the employment data from 2010 to 14 for both of these regions. This data is reported at a monthly frequency and provides us data on the number of days an individual is supplying to the labor market in different types of employment. We also have earnings data if they are employed in paid farm or non-farm work. Our climate data is coming from IMD, and we define our drought measure as the monsoon rainfall in the bottom two deciles of the long run average rainfall for a given village. Here, monsoon rainfall is the precipitation received in the months of June to September, and our measure is similar in spirit to the one used by Jayachandran in her study. our estimation strategy. So we are able to identify causal impacts given the exogenous nature of these rainfall shocks. And we are using household fixed effects model, which allows us to address any heterogeneity at the household level in the unobserved characteristics. So we are doing the analysis wherein we are first looking at the, how the drought shock is affecting the usage of farm input. And for this, our estimation equation is as follows. We are regressing our dependent variable on our measure of drought. Here, alpha 1 is our coefficient of interest. Our dependent variable here will be the labor hours for the farm input usage, which we are looking at the total labor hours, and further bifurcate into family labor hours and hired labor hours. Later on, we also explore the operation specific labor hours. We have transformed our dependent variable using IHS transformation, that is inverse hyperbolic sine transformation. This allows us to interpret our coefficient of interest alpha 1 in percentage terms. In our specification, we have season fixed effects to control for any seasonality in employment. We have household fixed effects to take care of household level heterogeneities. We have time fixed effects. In addition, we control for village specific linear time trends to allow for general trends over time within a village. We are also controlling for time varying household characteristics. And our standard errors are clustered at the village season level. We next do the analysis to look at how the labor is responding to a drought shock, wherein we are regressing the work days of labor, female as well as male labor, on our drought measure. Here, alpha 2 is our coefficient of interest, and again we have IHS transformed our dependent variable. Therefore, our alpha 2 coefficient can be interpreted in percentage terms. Our dependent variable would be the workdays in different types of employments, the wage earnings they are earning, as well as migration and distance to work. Here again, we have season fixed effects, household fixed effects, and time fixed effects, and also village specific linear time trends. We control for the same set of household characteristics here, which we had controlled for in the previous analysis. In addition, we have individual specific controls, they being the age square, years of education and its square, and the marital status. And here again, the standard errors are clustered at the village season level. So we begin the analysis with a test of the validity of a drought measure. Whenever there is a deficient rainfall, we expect that the yield on crops that are water intensive like rice should be falling, while the effect on other crops that are not using water so intensively can be ambiguous depending on the drought measure. So on expected lines, we do find that the yield for rice is falling significantly. There is a fall of 49% in the yield of rice, while pulses and oilseeds, which require less water than rice but more than coarse cereals, are also having a negative coefficient, but this is imprecisely estimated. Now, as an alternative measure of farm productivity, we also look at what happens to the revenue of the household, and we find that there is a fall in household revenue by 30%. Thus, these results indicate that our drought measure is accurately capturing deficient rainfall, and this allows us to move on with our analysis. So I present to you our first set of results wherein we are looking at the effect of drought on farm labor use. In panel A, we are looking at the effect on the absolute work hours, wherein we find that whenever there is a drought, these cultivating households are reducing the usage of female labor by 52% and that of male labor by 21%. And clearly, the usage of female labor is falling significantly more than that of male labor by 31%. Then we bifurcate this effect into family and hired labor, and we find that the family female as well as male labor, both of them are falling, and there is no gender differential in the usage of family labor as both of them are falling by a similar magnitude, while the hired labor is falling significantly only for the female members. So what is happening is that whenever these households are faced with a drought shock, they are reducing the usage of labor for female as well as male labor, but there is significantly more reduction of usage of female labor on farm. Now, it is possible that this reduction that we are seeing here could just reflect the reduction in the area cultivated by these households when they are faced with a drought. Therefore, in panel B, we further look into what happens to the intensity with which labor is being utilized on farm. So here we are looking at the effect on the per acre work hours, and we find that whenever there is a drought, these cultivating households are reducing the usage of female labor. So there is a significant reduction only in female labor, and this is most of this is coming from a reduction in hired female labor. So these results indicate that the usage of female labor is falling not only in absolute but per acre terms also on these uh, on the farm. Next, we try to understand what is happening. So, how these individuals are responding to a drought shock by exploring the effect on their farm and non farm work days. We find that whenever when they face a drought, female individuals, there is no change in the hired farm work days for female or male individuals, while there is a fall in the family farm days of the male members, while there is no effect observed for the female members, although we do see that there is a negative sign here which is imprecisely estimated. The workday spent in caring for the family livestock, on the other hand, is falling significantly for both female as well as male labor, for female as well as male individuals. Interestingly, when we come to the non farm hired work days that male members are supplying to the labor market, we are seeing that there is a significant increase uh, in the days that they're supplying to non farm work. Therefore, we see that the male members are diversifying from the farm's work to the non farm work. Women, on the other hand, are not able to do the same despite having a similar effect on the livestock care. Now, an obvious question from here is, if the workdays are falling more for women and they are not able to diversify like men, then what is happening to the wage earnings of these members? So, next we look at the effect on the monthly wage earnings of these members. Kindly note that these wage earnings are reported only if they are employed in some kind of paid work, paid farm or paid non-farm work, and not if they are doing some kind of if they are working on the family farm or taking care of the family livestock. So what we find is that the monthly earnings are going up by 22% for the male members, and this is coming from an increase in the non-farm earnings that they are getting by diversifying to the non-farm sector. Clearly, the difference between the female and the male earnings are going up significantly. Therefore, we see that women's relative wage earnings are falling significantly. Taking these three results together, what we have is that female labor usage is falling significantly more on these farms. They are not able to diversify to the non farm sector like male members, so they are losing on their relative earnings also. We have checked the robustness of this set of results using a number of checks wherein we considered a balanced sample for both the analyses. Also, our farm input analysis in the main specification is based on cultivating households. What that means is that households that are contemporaneously having a positive amount of area cultivated in a given season and year. So, what we do is we extend the analysis to ever cultivating households, as the decision to cultivate may itself be endogenous toward the drought shock. But our results remain consistent, and uh, they are qualitatively the same. Also, the individual level analysis that we have done had household fixed effects and had controls for individual characteristics. We considered a stricter specification wherein we introduced individual fixed effects, and the results continue to hold even with the stricter specification. In our main specification, the standard errors were clustered at the village season level. So, as a robustness check, we are clustering at a higher level, which is the village level, and our results remain qualitatively the same. Therefore, we are confident that our results are not driven by any of these concerns and are robust to all of these checks. Now we try to understand the underlying mechanisms for those observed gender differentiated impacts. We found that the farm labor adjustments were were reducing the usage of female labor more than that of male labor. So, why that might be happening? The existing literature has established that there is a gender division of labor on farm, wherein the male members are majorly responsible for the preparation of land, they are doing the tilling and the plowing, while the female members are majorly responsible for the weeding and the harvesting stage. In our data also we find that while the male members are majorly invested with the preparation activities, the female labor is disproportionately doing the weeding and the harvesting operations. The sowing stage uses both female as well as male labor in a similar magnitude. Now, consider the situation given that the operations in agriculture are performed in a sequential manner, starting with the preparation of land, which in the Kharif season is majorly done before the onset of the monsoon. So this stage is less likely. This stage is likely to have lesser effect coming from a drought shock, while operations like weeding and harvesting, which are the downstream operations, are likely to bear a larger effect of the drought shock. That is also going to happen because weeding, so weeds in themselves need water to survive. So if there is a drought like situation, weeds will themselves die, and this will reduce the uh, requirement for having weeding labor. Harvesting requirement can also fall because the yield is going down, as well as the cultivated area might reduce, leading to lower requirement for having harvesting labor. Therefore, we try to see what is happening to the area that is operated under these operations. And we,
Nikita, got about 9 minutes left.
thank you. So we find that there is a significant fall in the weeding and the harvesting operation as expected. While there is no significant fall, although the land prepared is negative, but there is no significant fall observed here. Therefore, we have done the analysis looking wherein we are doing a heterogeneity analysis by these operations. So we look at the labor utilization in different operations separately, and we find that there is no effect on the labor, on the usage of labor in absolute as well as per acre terms in preparation of land, while there is a significant reduction in the usage of female as well as male labor in absolute and per capita terms for the weeding operation. While for harvesting, we are seeing that there is a significant reduction in absolute and per acre terms only for the usage of female labor. This shows that it is the underlying division of labor that is resulting in the gender differentiated impacts that we observed in the farm labor adjustments. Next, we try to explore what is happening to the individual labor adjustments. So we found that women were not able to diversify to the non-farm sector and was experiencing a reduction in their work days. So and there could possibly be the channel of mobility that literature has established, that women prefer to work near to the premises of the household, and they are less flexible in terms of the distances that they are willing to travel. And there can also be a possibility of a skill deficit, wherein it's possible that women lack the skills required for non-farm work. So we try to explore which of these effects is leading to the gender differentiated effects that we have observed. And what we find here is that while male members are more likely to migrate, there is a uh, female members are less likely to migrate when they are faced with a drought shock. Therefore, we see that the migration channel is available more for the male members, and it reflects the mobility restrictions faced by the female members. And we also explore what is happening to the distance that they're traveling to work, and we find no effect here. Now, this distance measure is available only if someone is traveling outside the village. So, conditional on someone moving outside the village, we see no effect on the distance to work, but male members are more likely to migrate. Next, we try to explore, which type of work days is it that is affected more, and we have a very interesting finding here, wherein we find that the female members are increasing their Narega work days. So Narega is a public works program with the mandate of 30% of the work reserved for women. So this employment guarantee scheme is enabling women to offset some of the negative effect coming from the rainfall shock. While male members are more likely to increase their salaried work days. I don't have the skilled work days reported here, but what we find is that there is no effect on the skilled work days coming from drought on female or male members. Therefore, it is not as much the skill issue, but the mobility restrictions that are leading to women not being able to diversify. Therefore, I conclude that we do have evidence that there are gender differentiated impacts wherein the female members are bearing a higher cost of the shock and they also lack coping mechanisms. Therefore, a negative productivity shock can exacerbate the gender disparity. And it is important to keep in mind the task based gender division of labor when looking at the effect of these negative productivity shocks. And thank you so much for your attention. And I would also like to thank the organizers for giving me this wonderful opportunity to present at this forum. Thank you.
Perfect. Yeah, plenty in time. So can move on to the discussant. Sheetal Sethi from UVA.
Um, Nikita, thank you for a very clear presentation. I think you present very well. So everything was very clear. So kudos to you. That was very well presented. So I think that I have some comments. So I think this is a very important question. The research is trying to understand if climate change is going to have distributional consequences and whether women are going to be affected differently uh, relative to men. And this is very important to establish, because down the road, if we want to try and set inform policy, then we need to understand how different genders or different types of populations or subgroups might be affected. The paper is written very clearly, and so the authors have done a great job at clearly delineating what they are doing. Careful attention is paid to identification as well as inference, talking about uh, um, what type of clustering is happening, for example, or how do we think about identification and fixed effects, etc. And what I found really interesting was the farm labor use, that the weeding and sowing goes down, and that goes down differentially for females. So this task oriented examination of this agricultural practices, it's very interesting, and I think that that's an innovation in this paper. So I think that there are some questions, or just take these as comments, and um, you can try and address most of these. So first thought I had was, why are you using ICRISAT? The downside of using ICRISAT, I understand there's an upside. It's very frequent. You have monthly information, and maybe it adds to your power, but the downside is it's only 30 villages, and so and it's rain-fed agriculture in the tropics. So it's not very generalizable, and I think that it was also the rice that you see major yields declines in. So I'm not sure why is it, where would be the generalizability from it come from. Why don't you use Eris reds? Because you can go back many years and decades, and they follow same households over time, and I think they have detailed information on weeding, etc. as well. But that said, I mean, you can complement this analysis with the reds and see in other types of agri-climatic conditions, what is happening. So for example, Haryana and Punjab produce bulk of India's rice, so but they are also reliant on irrigation. So do we also see this happening there? Or because the paper is about climate change, so we want to understand in different geographical settings what is happening. The other benefit of doing that would be to look at different other crops as well, because it could be that there are there are crops that are more women specific. So ideally I would like for you to hold constant the crop and then say within that what's happening, but it could be that some crops have comparative advantages for women and others don't. And so is it the case that we can learn something about that from looking at a wider geographical spread? um, how is weeding affected during water abundant times? If you can shed evidence, that would be very interesting as well, because you said that weeds are sensitive to watering. Then I think your specifications would require controlling for temperature as well, because yields are significantly affected by temperatures, and so many other things can be affected by both. Droughts happen at times when the temperatures, especially in this belt that you are looking at, escalate as well. So you want to nail that down as well. Um, but you do have the village trends, so it could be that if that they absorb this, but if the paper is about climate change, then it would also be interesting to look at differential effects of temperature, if any, for women versus men. Then the other thing is that you've used wages and earnings data, and I was wondering if there was missingness. Usually in surveys, there's a lot of this missingness on wages. And so how do you treat those observations, and what is the size of missing data on wages and earnings? From your specific paper, you don't find individual of labor effects. You do find that, in the cultivated households, the farmers, they are less likely to employ women, but when you look at individual labor, you don't find an effect. And you allude to the fact that maybe they are hiring women from other nearby villages. Of course, with the research, you won't be able to look at it, but in that sense, then it makes me wonder what is the right size of the market. The is it a block? Is it like a tehsil, or how far would, on one hand, it seems like women are not prefer working close to homes, but on the other hand, it seems like they are being hired from nearby villages. So it was there's some seems like some contradiction going on there. And so you may want to think about what is the correct size of the market. Are these women married? What are their ages? Because poverty and drought related poverty can also have effects on marriages and marriage markets, and that can lead to attrition or changes in the composition of women that are available. So that's something to think as well. So maybe the women usually who come to weed are very deft at it, but then if the deft women got married, then the skill deficit increases or such. On footnote 23, you mentioned, okay, this could be a supply effect as well. There are alternative channels. I think that warrants a different section, and you instead of just a footnote, head on address to the best possible way whether this is demand or supply, because you're trying to parse that out. The reason I think supply effects are plausible is because when droughts happen, women's time use can change. So for example, women fetch fodder and women fetch fuels and women fetch water. So if there is a drought and they have to go farther to fetch these things, naturally they can't supply labor. So it's not clear to me whether you can rule that out or not. Then about resilience and adaptation, you talk about migration and non-farm sectors, but it is the case that these things themselves are affected. So are we looking at local economies, or are we looking at migrations across economies, and what do we think about the market integration? So in the sense that if you're looking at non-farm labor in industry, then industry itself might be affected by directly or indirectly by rainfall shocks, because their inputs become more expensive, or because of poverty, their products are not being bought. So it's not clear to me why we think that non-farm sector is a good way to adapt. If you can shed more light on that, and where, how far, maybe the shocks are not correlated, to say you're going too far away from where you are, and that place hasn't experienced a negative shock, so that's what's going on, then you may want to talk about that. What I really found interesting was Narega employment increasing for women, and I would recommend that you explore that more. I vaguely remember there was some paper at some conference, sorry, I can't remember the title of this paper, but there was plausibly a paper that did look at just overall effect of Narega, but not looking at differentiated by gender. So I think that that can that affects and helps women. That is something, first order policy relevant. So play that up a little bit more and explore that more. Uh, and final set of comments I have is that if this paper is about climate change, then engage with that literature much more than you have done. In the introduction, I would recommend that you engage with the literature and say what do we know about these types of things in context of climate change. Is there heterogeneity by crops or rain-fed or non-rain-fed agriculture? Which other contexts are relevant for that will be informed by your study? So maybe other tropical areas in other countries. What's the policy relevance? So upfront in the introduction, make a engage in that discussion and that discourse. And climate change literature usually does the scenario type of things as well. And so you can say, if you know if the propensity of drought increases by this much, what would be the loss? So that is I think that would resonate with more broader sort of literature if you did that, and with the audience as well. So go beyond just making it a development paper. It can also be in, speak to the environmental side of it as well. So I think that probably was it. Yes. So
Okay, so we have about 8 minutes or so. So
Thank
maybe
you.
Kanishk, we can let Kanika respond, sorry, Nikita respond first to those comments, and then we can take more.
Yep.
Thank you. Thank you so much, Sheetal ma'am. All the comments, they are really helpful and insightful. And so a number of those we have worked on after, sending you the updated draft. So yes, I would like to, address some of them and clarify our stand, like most importantly being why ICRISAT, right? So the one major advantage that this data set is giving us over any other data across the world is that it's giving us the input usage by operation in a given season, right? And that is very important to look at the effect that a drought is going to have, because depending on when this shock is being experienced, we cannot really delve into these detailed analysis and mechanism if we do not have this data available by operation and season. Also, we sure can add supplement the analysis with the reds data, and that of course should make it stronger, make our uh, claims stronger. And then the second thing is about the effect of yield. So other studies that have found huge effects on the paddy and other crops. So when you are looking at districts, then it's a different scenario, but we are having a drought measure defined at the village. So it's possible that even a minor change in your rainfall can have an effect, can lead to changing the definition of your drought variable, right? And within a village, if the yield is going down, because an obvious response is to reduce the area, we do see that the area under different crops, almost all the crops, is falling significantly. But the yield here, since we are measuring given that you are still deciding to cultivate, so you will do that only if you have some availability of irrigation facilities or something to back up, right? So even if in that scenario we do find that there is a reduction in yield by 49%, so this is how we were confident, okay, this does capture deficient rainfall. So that is on the crop measure. And also other crops, right, the core cereals, since given we are in the erythropic zones, and their dependence on millets and sorghum and other crops which require less water is also very prevalent, and they are not going to be affected by a rainfall shock. So that is why we picked specific crops that are going to be dependent on water to look to validate our drought measure. And regarding your query on weeding, whether abundant rainfall, increases the weeding labor demand, yes, we do find that, if there is, in our specifications, we have control for the upper deciles of the shock also. But when we looked at the effect separately for those top two deciles, we do find that weeding labor goes up. So the first order effect can just be coming from the increased area that is, under cultivation. So if you are having more cultivated area, you have to weed, you are more likely to have more weeding requirements. So one effect is coming from that, and the other effect is coming from you have the water available, so weeds sprout more. So this insight of weeds requiring water came from the agri literature. So it was not there in the economics literature. It was during my visit to ICRISAT that I got to know about these details. And then next is temperature. So this is an excellent point. So yes, we did. So when we were running the initial stages of the regressions, we had temperature controlled for, but we do not see much variation in temperature for 2009 to 14, right? So this is not too big a time period to see variation in temperatures. So if we want to do a temperature analysis, then REDS would be a better data set to use. That is for sure. But if and what we can do is we can, in our set of controls, we can introduce this also and rule out that it's the effect might, in fact, I think the effect would be more pronounced, right? Because the temperatures are also falling, so that might also be leading to an effect. uh, Next is the missing wages and earnings. So one key feature about the ICRISAT data is that it's collected by the resident investigators who are staying with these villages in the same village, and they were like they know the economic system there very well. So we do not face this issue of missing wages or earnings. So so it was missing for less than 0.3%, 0.3% of the whole data. So this is not a big concern there. And also this is reported only if you're doing paid work, right? So then you are getting it, so you have certain kind of verbal or some kind of contracts going on there, so it's well documented. And given that it is collected on a monthly basis, so reporting issues are even lower in that scenario. um, then Right. So then is not being able to find effect on the individual labor responses, right? We did not find any significant effect on the hired farm work days, while we do find that the labor usage is falling. So what is happening there is, when we are looking at these household level analysis, we are looking at how the household's total usage of female and male labor is going down, right? But when I do the individual level analysis, so mm, as an individual, it is negative. We do have a negative coefficient, but it's not precisely estimated. So what we have done in the revised version is we have aggregated the individual data again to the household level female and male members. And then we are trying to see, if, because only then we have uh, the data at the same level as the household farm analysis. And there we do see that the magnitude of the effect is stronger. So yes, your point is right. So we need this kind of comparison where we are having household versus household comparison in input and the responses observed by the households, rather than looking at the individual analysis in that perspective. Also, there is one last point that I would like to address, and rest of the comments, of course, they are always welcome, and I will try to address them in the latest draft. So that is regarding the non-farm sector, right? So if these travel, so the thing is, most of the individuals in our sample, they were doing this non-farm work outside their village. So for almost all of the data that we have, they were moving outside the village, and for them the distance was getting reported, right? So now, given that our drought measure is defined by village, so this village is getting affected by a drought shock, it necessarily does not imply that the nearby villages will also experience the same shock. So that is uh, that is an argument that I can think at the top of my head, why that might possibly not why that is not possibly a big concern for us. But of course, the shocks can be correlated across these nearby villages. And we do see that the distance coefficient is positive, but given that it's not reported for all the individuals, and even deciding to work outside the village can be a selection variable. So maybe that is where we are losing power. But I will try to delve further into try to understand what is going on that front. So thank you so much. All these comments, they are just wonderful, and I will try to address all of them.